Hello everyone, my name is Leslie Stegmeyer. I'm a senior at Indiana State University, and I'm doing a report on underpinning for my Construction 418 Design Temporary Structures class. Underpinning is the installation of temporary or permanent support to an existing foundation to provide either additional depth or an increase in bearing capacity. These are some of the methods of underpinning: mass pour, conventional concrete pit, micro piles, soil nailing, bracket piles, jet grouting, screw piles and brackets, pile and beam, and piled raft. Mass pour is one of the most used methods, excavating sections in sequence to a pre-established depth below the footing and place the concrete into each pit. Conventional concrete pit is where you place small wood sheath pits constructed beneath the foundation to be supported, and then fill the pit below with concrete up to the underside of the foundation, and later dry pack the gap with a stiff mortar. Micro piles are installed adjacent to the structure to be supported. An earth retention technique for soil nailing is used to support retaining walls, stabilizing slopes, or excavation support. Bracket piles are used in conjunction with earth retention work to support and or stabilize existing foundations adjacent to a proposed excavation. The piles are installed in pre-drilled holes alongside the exposed wall or column footing. A bracket is mounted to the underside of the footing and attached perpendicular to the new pile to transfer the load below the excavation subgrade. Screw piles and brackets are used in instances where traditional underpinning is not possible. The screw piles and brackets can be used when excavation is needed in a great depth where a piling rig is just not able to get there and smaller equipment is needed. Screw piles and brackets can be installed by 2 men by hand. The advantages to some of these are little noise, minimal vibration, and a speedy installation. Piles and beams are a preferred method to alleviate the footing. They require min piles to be installed or on either side of the affected wall, where the brickwork is then removed and reinforced concrete needle beams are connected to the piles to produce the support of that wall. The advantages to this is it's suitable for restricted access, faster than traditional pinning, high load compatibility, less disruption, and less soil generated, and can be completed quickly. Pile raft is used when the entire structure is going to need underpinning. This is when the foundations are too deep for other methods and when the soils are too hard for small equipment that can't excavate to the required depth. Piles are placed in locations pocket below footings, are broken and replaced with reinforced needle beams to support the wall load. A ring beam is built to link these needles. The concrete is poured to form the underneath of the structure. Advantages to this is they provide lateral and transverse ties throughout the structure, economical at the depth greater than 1.5 meters, and you don't need external access to the building, and it reduces disruption of drainage systems. The history I found about underpinning is that the definition actually originated in the late 15th century, where they used system support beneath the wall or the like, action of supporting and strengthening from beneath, which was a figurative sense of prop and support that was recorded back in 1580. The subject of underpinning the foundations of buildings is an old and vast one. John Addison reported that on the arts of building that Leon Battista Alberti was one of the first people to recognize underpinning. He was an Italian architect from the mid 1400s to the late 1400s before his death. His classic architecture can be seen in the church listed here. And the columns, that they weren't just used to be decorative, but they were actually functional and load-bearing. Underpinning is worldwide. This has been documented in Nigeria, San Francisco, New York, Malaysia, Australia, and England, and many other places around the world. Uses of underpinning is for the settlement of an existing structure, construction of a new project with deeper foundations adjacent to an existing building, the changes in the use of the structure, and addition of a basement below the existing structure. The fundamental components of underpinning are site-specific plans and details and sequence of work, monitoring by an engineer of adjacent structures and properties, pre-construction reports for protection and support of adjacent structures, frequency and duration readings, location, types of instrument, permissible movement and vibration criteria, and they must be started from the corners and work towards the inside of the building. Underpinning shall be designed as a permanent structural element. Underpinning shall be designed and installed in a manner as to limit lateral and vertical displacement of adjacent structures. And underpinning shall take in account the effects of foundation and structure produced by the lateral earth's pressure being exerted. These are some of the case studies I found about underpinning. There were 3 cases in which they were all different. Weather was the cause of the destruction of a 4-story building adjacent to a high-rise complex that was being renovated. They had done everything right, but due to the water and the old foundation of the existing building, it caused the building to settle and had cracks in the walls. Another case was improper underpinning and excessive excavation. An example of this was in the 1980s, where it caused the destruction of 3 old buildings in Lexington, Kentucky. The excessive excavation undermined the footing, causing the 3 older buildings to collapse. The contractor was required to rebuild those buildings, but there weren't any injuries reported. Another one is human negligence. During the examination, a consultant missed an underpinning in a basement wall, and the excavator extracted the soil around it, causing damage to the footing, and produced a lot of settling to the structure. And even though the contractor took immediate action and stabilized the building, the contractor was sued. Temporary structure failures. Most often the failures in underpinning cause structural damage to adjacent buildings, injury, loss of life, extensive property damage, construction delays, and expensive litigations. The causes of these are lack of underpinning, inadequate underpinning and bracing, over-excavation, impact from rubble foundation, and impact from soil and groundwater. OSHA doesn't have exact regulations on underpinning, but there are a few mentioned of underpinning foundations. Only some of the local states hold regulations about underpinning for foundations, like New York City requires controlled inspections of the underpinning of foundations, but no other specific specifications are provided. I did find in the OSHA construction that where the stability of adjoined buildings, walls, or other structures is endangered by excavation operations, support systems such as shoring, bracing, or underpinning shall be provided to ensure the stability of such structures for protection of employees. And the other one was a support system such as underpinning is provided to ensure the safety of employees and the stability of structure, which really is saying the same exact thing as above. This is the church that was designed and built by Leon Battista Alberti. He liked geometric shapes and understood them very well. This is a picture of the California Palace of the Legion of Honor in San Francisco, where 46 of the columns were supporting a load of over 250,000 pounds, so they could put in new service and ventilation tunnels underneath the existing structure. This is an example of underpinning in England and in Brooklyn, New York. And this is an example of residential underpinning, commercial. This is an example of the underpinning that I could find. It's where the rubble wall condition is questionable and they need to put pinning in for the soil to not compress so much. Here's another example of underpinning. And these are my citations for my report. I hope you enjoyed my video about underpinning.